Хто ще не зареєструвався, то, будь ласка, підходьте, реєструйтеся, бо ми в кінці і ще десь так хвилин 5-10 і ми починаємо, добре? Може ще хтось дойде і
Так, як то скинути лінк? Каже, скинути лінк, щоб там не на Фейсбуці. Що? 10 починає. Людей? Десь виглядає більше.
Вони ще реєструвалися.
Що? Та мені здається, що треба, бо зараз ще прийде.
Може, ти англійську?
Це?
Може, ти англійську?
Ні, я слабенька.
Я зловить.
Це?
Я зловить.
Це що?
Та зараз побачимо. Всі ж свої. Там, якщо що... Да, ні, ну, так. Чуєш, а ти з Дімою домовився, що не буде? Чи так вона просто? А, Олексій домовився. А там Андрос написав. Ні, він просто ж, я ж не знав, коли воно буде, чи це.
Ясно.
Ну, він сказав, що так, він зацікавлений. Скажемо, що ведемо перемовини.
Ну, то добре, то не...
Ми знаєш, як робили? Ми робили, що ми
Ти заступив
Ми-
в трансляції.
ми виступали. А потім, коли вже задаєш спікера, а потім йому вже кажеш, stage is yours, let's go. Я думаю, що нормально. У нас через нормально, тільки спікер говорив, що.
А на що тоді частина перша?
А там тоді подивився. Це вже в разі лопати.
Так, ну, танц має, але хай включиться.
Всім дуже дякую за те, що завітали до нас на Meetup. Ми дякуємо. І в нас є трішки такої цікавої інформації про те, як ми готувалися до цього мітапу. Ми збирали від вас багато досить інформації. Так? А зараз ми ту інформацію трошки оцифрували і хочемо з вами нею поділитися. І також дякуємо нашим спонсорам, без яких ця зустріч не відбудеться.
Отже, в нас є 205 реєстрацій, але, як бачите, не всі змогли прийти. Якась певна частина з цих 205 реєстрацій була реєстрація на онлайн участь, тобто люди дивляться нас зараз в онлайні, тому якщо будете проходити, скажіть привіт.
І трошки детальніше для нас стало відкриттям те, з яких джерел люди переважно реєструються до нас. Тому якщо у вас буде нагода також організовувати власні події, то ми рекомендуємо також звернути увагу на декілька джерел, яким можна залучити людей до участі у зустрічі. І здивуванням, наприклад, для нас стала платформа Meetup.com і Go.ua. З нею ми отримали практично половину всіх наших реєстрацій. А друга половина, яка зараз є зелена, то ми просто не знаємо, звідки люди до нас прийшли, бо ми почали збирати ту інформацію десь тільки з середини нашої відкриття реєстрації.
Тепер трошки про географію. Звичайно, найбільша кількість людей зі Львову і околиць. Трошки ми маємо з Кропивницького, я не знаю цих людей. Маємо Київ, маємо Сумикарів, але напевно, що це люди, які приймають участь онлайн. Тобто їх зараз тут немає. Якщо є хтось з цих міст, то, будь ласка. О, круто, а ви звідки? Суми, круто. Ви спеціально приїхали сюди? Круто, класно.
Також ми збирали інформацію про те, щоб зрозуміти, з яких компаній люди до нас завітали. Сьогодні є в компанії ПАМ корпоратив, але я бачу, що досить багато людей все ж таки з ПАМ завітали. І тому наступного разу, якщо ви хочете бути першими на цьому слайді, то я прошу вас, щоб ви залучали своїх колег і казали, реєструйтеся, правильно вказуйте свою компанію. І, можливо, наступного разу ви вже будете на першому місці, а не якась інакша компанія.
О, ну тут взагалі все погано. Кого ми тут маємо? Ну, звичайно, половину ми не знаємо, бо ми почали дуже пізно. Але, як бачите, в нас є і девелопери, і адміни, і пітоністи, і кого тільки нема. І це дуже добре. Це дуже добре. Чим більше людей, хороших, різних, тим краще буде наш івент.
І це є наш розклад на сьогодні. Тобто ми запросили 3 відомих спікерів з світу Postgres. І першим буде доповідати Ханс з своєю доповіддю про те, як діагностувати проблеми в Postgres. Потім Аліція і також Олексій розкаже нам про патроні. В перерві між цим у нас ще буде такий вже вечеря, майже, тобто вже пізна година, так ще буде піца-перерва. І також, як минулого разу анонсувалося, якщо у вас є якась ідея, якщо у вас є якийсь open-source проект, або у вас є якісь речі, які ви робите, і ви хочете з тим поділитися, то ми вас запрошуємо до такого 5-хвилинного спічу, на якому ви зможете поділитися з нами якоюсь цікавою інформацією, яку ви робите, і хотіли би з нею зі всіма поділитися. А можливо, от такий досвід 5-хвилинний, він потім переросте в повноцінну доповідь. Тобто можна зараз почати з чогось маленького, навіть без презентації, просто з нами поділитися інформацією, а потім вже на наступний раз ви підготуєте повноцінну презентацію і зможете нам її показати. Не забувайте за реєстрацію, тобто в нас в кінці буде розіграш, і може на каву перерві, на піцу перерві підходьте сюди і позначайтеся в списку, бо ми будемо розігрувати наші призи серед тих, хто зареєструвався. Для того, щоб потім також відслідкувати, можливо, збудувати якусь статистику. Ми, наприклад, порахували, що 40 людей, які зареєструвалися минулого разу, вони зареєструвалися і зараз ще раз. Тобто у нас є ком'юніті, яке росте, і ми очікуємо, що воно буде рости і далі, і тому хочемо мати ту інформацію, що ми є і куди нам рухатися далі.
Ну, прийшов час. За автопаті. Вибачте, головне я забув. У нас буде автопаті, так? В тому самому місці, де ми домовлялися. Тобто в нас буде автопаті, я не можу вимкнути це назву.
Тобто на 9:30 ми запрошуємо всіх на другий поверх в ресторан Єгерваль. І в нас є частинка коштів від наших спонсорів, і ми ті кошти витратимо на закуски, так? А алкоголь, то він вже буде там, можливо, з кишень бажаючих.
Ну, дивлячись, скільки вас буде, якщо вас буде дуже багато, може ми вам не даємо. А якщо вас буде дуже багато або усі, то будемо, як казали, хворі спартанські діти, будемо спілкуватися.
І першим нашим доповідачем є Ханс. Ханс має більше 20 років досвіду з Postgres, є засновником і SEO компанії CyberTech. І зараз запрошуємо, щоб поділитися.
Dear Chief, the stage is yours. The food was here and Does it say something else? No. The signal is being processed. Steve, yeah. So, latest version. So, good afternoon, everybody. Thank you for joining. Everybody hear me back there? Yes, cool. So, good to see you. Good afternoon, everybody, and good evening, Lviv, right? Yeah. So, my name is Hans-Jürgen Schöning. Don't bother. Just it's easier. Right? So, I'm from the land of Austria, which is, you know, the guys who keep occupying people around the area. Today's topic is performance tuning of Postgres, some 5 minutes assessment. So if you're running Postgres, what can you do to figure out in 5 minutes how things work? So just a brief introduction, we happen to be a Postgres company for 20 years. So we started in the year 2000 when I was still young and not, and I used to have hair, you know. So we're doing all kinds of Postgres stuff, and we have a couple of offices around the world. So. And I'm glad that Pablo gave me the invitation to come here after I survived him flying. But I'll show you a picture later. So, inspiration. Last year, I happened to attend a customer in Germany which is making those fancy BMW cars. And this inspired this whole talk, you know, because they had some nice and interesting problem. They had a table in Oracle with 340 billion rows. And everybody wanted to run Exadata because it was so cool and it is so fast and it's so miraculous and everything. And what they tried to do was actually to run a query which said, count me those 340 billion rows except those 8 billion. And they were wondering why this stuff was so slow. Right? And then they tried to figure out what's the point of this query, why are you doing that? So they were on the verge of spending 4 million euros on hardware, but nobody knew what the hell this query was good for. But they wanted to scale it up, right? But nobody knew, this whole bloody enterprise knew what this whole query processing 300 billion rows was good for, right? So this inspired me to a whole range of performance talks on Postgres. So, how do you fuck up properly? How does it work? I think some of you know how that works. So joining up 500 tables, doing no pre-aggregation, and have no clue what you're doing, right? That's usually a very nice way to get it done. So one thing you should keep in mind is when you have a small data set, say million rows, 100,000 rows, 5 million rows, you can basically do what you want. The hardware is going to bail you out. So if you do a sequential scan on 50,000 rows, the hardware is going to take care. Right? It's not like in the old days, hardware is going to take care. But as soon as you go into serious business, so if you have 1 billion rows, if you have 50 billion rows, then hardware is not going to bail you out. Because if you're reading through the whole phone book of China, it's a hell amount of people, right? And why do you read anyway? Because everybody's called Lee. So in this case, and what you usually have to keep in mind, this is the first thing, when I read my emails, this is the first thing. Can you tune Postgres? And the answer is there is no magic parameter which says fuck off. Doesn't work. There's no such thing as fix me, right? Because if this parameter existed, trust me, it would be turned on. There is nobody sitting there in the Postgres community turning off the performance parameter, so just like people like me can turn it back on again, right? That's not the case. There's no such thing as speed on. It doesn't exist. There's only one thing which does exist, which is brain on, right? That's harder. So, one thing which is also quite important, favor real data over hallucinations. What does that mean? I think that if we add 500 more disks, things are going to work out perfectly. No, they don't, because you have 2 megabytes of data and 2 terabytes of RAM. Right? Disks are not going to change anything because you don't use them. Right? The same way if we do a bigger server. If you double the speed of the server, but if your bloody query is fucked up by design, right? You might be able to increase your data by a bit and you're still back in trouble, right? Hardware is the last thing. The only problem is people think that bigger hardware makes the replication more important, but actually it just shows how stupid they are. You know? There is no database application in 95% of all cases which ever is going to use 70 CPU cores. Never, right? That has to be very, very specific use case or something really, really hard. But in 99% of all cases, there is no application which needs 70 cores, unless you're Facebook or something, which is not very likely. Okay? So, instead of hallucination, the point is get real data, which means measure. And what people usually do here is, something is broken, and then they draw shiny pictures on the wall, load graphs in red. So if your car is broken, and you put a picture on the wall, how does it change your car? Usually it doesn't, right? And because your car is still fucked up, what you do is you take a second picture, right? You put it on the wall and make it even more colorful. Still doesn't work. Surprise, surprise. So the answer is, right? And if that doesn't work, you try to imagine why something is wrong. Instead of looking at the car, you say, let's fix the engine. But actually you ran out of gasoline, right? Okay? So that's typical use case. If we do this, something miraculous might happen. If we burn a virgin, right? Winter is gonna end. And it works once or twice a year. To burn a virgin is gonna be spring. Perfect, right? Let's burn virgins, right? But it's not gonna change stuff. So what you really want is there is an eternal truth. And trust me, it's eternal. It says query cause load. So instead of looking at your survey and think, what could we do? There is one thing which is perfect. Look at your bloody queries. Don't paint load graphs or put pictures on the wall. Just look at your bloody stupid funky queries. And this is going to fix stuff. How can it happen? Perfect. So log files are kind of nice. But the problem is if you have a log file with a billion entries, usually on a big system, you don't care about individual queries. It's more like socialism for queries. You know, you think about the average query causing load. So it's not big query usually. It's a type of query. It's a million queries. It's more like, as I said, socialism for queries. Everybody counts. So in this case, there is a perfect module for Postgres, which is called pgstat statements. And in my personal opinion, it's a must. If you really want to figure out what is running on this bloody server, this is truth. If only this module existed, if you have only this module and you know nothing about the replication, you're still going to be able to pinpoint, say, 85% of problems, right? You're still able to focus on the most important stuff. So let's take a look. pgstat statements. What you got here is the query. So select star from phone book where name is Jane, Jack, Joe, whatever. And in Postgres, this is going to be the same query. It's going to be where name equals question mark. Okay, it's going to be the same query. And it's going to get you the total time. So even if you're super, super stupid, you should be able to do select star from pgstat statements order by total time descending, and the most time-consuming stuff is going to show up on top, right? And then you can work through it. So even if you have no idea what this application is going to do, if you order by this field descendingly, shit is always on top, right? Look at water. Good morning, Sister. So this is how it's going to be up, and there is one mathematical thing here. The second query in this listing can only be max 50% of the problem. The 20th query can only be 5% of the problem, right? That's sort of true, mathematically, because otherwise it would be off. So if you sort descendingly, if you sort by relevance, do it. Of course, there's going to be this stupid query, some stupid, behind some stupid button, but overall, that stuff is going to be on top, right? There's more. Mean time, max time, average time, standard deviation, and so on and so on. In some cases, let's suppose you do select count star from your Chinese phone book where name equals Drozhnievsky. There is nobody gonna be in the Chinese phone book whose name is called Drozhnievsky, unless it's the Polish ambassador. But if you do select star from phone book where name is Lee, it's gonna be 400 million people. You know, I've been to Tunisia before the revolution. I'm not sure if there's a correlation. And I had 8 people in my course, 7 men and 1 woman. And out of those 7 men, 6 were called Muhammad, right? So if you want to make 2 million people open the window at the same time and go to Cairo on Main Square and say Muhammad, right? And 2 million people will turn around. So in this case, the phone book is going to be super fast if you're looking for Drozhnievsky or something, but it's going to be super slow if you're looking for Li in China. So this information about mean, max, standard deviation, etc., can be very beneficial. It can point you to locking problems. It can point you to diverse result set. It can point you to a lot of stuff, right? But at least you know, in average, this thing is going to take 5 milliseconds. And then the human has to decide if 5 milliseconds is justified for this type of period. There is no such thing as 1 minute means slow. 1 minute could be super cool. 1 minute could be a disaster. So you certainly need a human to take a look, right? And also there's something hidden here, which is the rows. If you have a query and you got it 1,000 times, but what you got is 100 million rows, what are you doing here? There's a typical use case. People, you have a search form. People enter something into a search form, press the button, and then the application is going to tell you 692,000 pages. What do you want to know? If you have more than 1,000 pages in your result set, your query is wrong. Why do you tell the user that it's exactly 629,304? Why do you care? You can't fix that. It's broken, right? But it's broken by design. Or I think the technical term is FUBAR, fucked up beyond repair. Okay? So that's also important. If you run this thing 10 million times, how many rows did you get? Right? That's super, super relevant. If you can only read this stuff, you already got. Second thing is caching. What PGStat statements is going to give you is a cache hit rate per type of query. Your overall cache hit rate says nothing. Right? If you look up the phone book 20 million times, 90% cache hit rate can be a bad thing. If you do select count star on 100 terabytes, 1% is a good thing. It depends on what you're doing, right? There is no such thing as you need 90% of cache hit rate, right? You really have to think about what does it mean. And this is going to tell you per query. And this is going to answer the question, if we add 1 more terabyte of memory to our 5 gigabyte database, does it change anything? The question is not, does it change anything? The question is, where does it change something? Right? Because you see where to have a chance to get more data or to get more information. Next thing is I/O. 10 blocks I/O. Select star from blah blah order by. Taboo. Big query. And this piece is going to tell you this type of query is doing some strange kind of I/O, right? For whatever reason. Can be missing index, can be stupid query, can be great index, which is fine, whatever. Okay, but it's going to point you exactly this type of query is going to this. It's not like the database is writing to this, it's you, right? It's this bloody query going to this. And finally, there is a feature which is called I/O timing, written by a guy from Estonia. Block read time and block write time, which is going to tell you when you did I/O, how much time did you spend on I/O? This type of query took 10 minutes. 3 of them are in I/O, which means 7 minutes must have been something else. So if you have a query which takes 10 minutes, and I/O is 0, how much are you gonna get out of more disks? Nothing, because you don't use it, right? That's super, super simple. You can figure out. The problem is I'm making a living out of this stuff. So obviously it's not so simple as people might think. Of course it's simple, but it's not something you couldn't have figured out, right? It's just a method of approach. Sort by relevance, which is time, and then work your way top down. And trust me, after 5 queries, life is good, right? Life's good. And this is a miracle query. This paid for my house. Perfect stuff. What's it gonna get us? It's gonna say, forget the substring, it's only to make it fit on one page. It says, give me the total time, round it to 2 digits, give me the number of calls, give me the average duration of a call, and this is basically percentage, right? This is what you're gonna get. This query, 126 seconds, 1.1 milliseconds in average, 55%. This type of query, 96 seconds, blah, 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 0.8 milliseconds, 42%. Trust me, this one is not your problem. Right? The slowest query here on the screen with 200 milliseconds is not our problem, because obviously it's bulk loaded. That says something about the slow query log. You're gonna catch create index, imports, transformations, backups, stuff like that. Okay? In many cases, it's these million calls of 1 millisecond which make up 97% of your entire system. If you just manage to remove this query because you figure out you just don't need it, we can go without. You doubled your speed already by optimizing way more 1 millisecond query. Right? This is truth. You can do hallucinations, as I said before. You can hallucinate of what might be helpful. We might want to add more disks, etc. To do what? To speed up 1 millisecond query? There is no I/O in a 1 millisecond query, because if there was I/O, it would be 20 milliseconds, right? Okay? It's that simple. Remember this query, it's going to pay for your house, or for my house, depending. Okay, this is proof. Query, how often, how long in average, percentage. Right? That is truth. And if you fix that, you actually know what to look for, right? You know, it has to be one of those 5 queries. It's not your load graph, it's not load 7, it's not your cache hit rate. Those are all problems down the road. The first thing you have to know is what to look for. And it has to be here. It has to be here somewhere. This is not your problem. Okay, usually not. I mean, this could be one button once a year. So if you press this button once a year, then things are slow. This could be this kind of query. But this is when people use their phones. And alerting is pointless. When the application doesn't work, people complain a lot faster than you monitor system storage phone. Okay? So, any questions so far? Missing indexes. 70%. It's really as stupid as I say. There's nothing fancy here. Nothing fancy. Nothing. 70% of all performance problems are missing indexes. Internally, I read recently on our company Slack chat, somebody went out to a client to do support and consulting, and he came back and somebody asked, missing index or real consulting? Question mark. The answer is usually missing index, right? The most dangerous sentence in the world is indexing is almost right. If I shoot at you and almost missed you, it's a headshot. You did. That is almost right. Almost right is wrong. If you come home at school after an exam and you tell your dad, I almost made it, it means you fucked up, right? That's what it is, right? And the same as with indexing. If you have one missing index on 1 billion rows, you did, So, what are we looking for? We're looking for expensive scan happening often. Many people think that reading a table completely is evil by default. It's not. If you do count star because you want to know what's in there, reading the whole table is fine. The question is, why do you read the whole bloody table 10 million times, 10 million rows times 10 million times? It's a huge number. That's the number of rows you're going to process. And ask you a question. If I give you a phone book, 1 million people, and you're looking for one person, and you read it all to find one number. Then I'm gonna ask you, find the next person. You're gonna read the whole phone book to find one number. They're gonna put you to an insane asylum. You know, it's a medical issue. They're gonna lock you away, right? In database work, they don't lock you away. They give you better hardware. They give you a better phone book to read. You know, you're gonna optimize how you turn the pages, you know? Right? And you're gonna do pre-read, or maybe you find 5 people to read the phone book concurrently. Or maybe you hire people with a bigger brain, you can catch more phone numbers to go for them sequentially. But in reality, they all end up in hospital for the mentally ill. Right? If you read from 10 million rows 10 million times, you're gonna go to hospital, right? If you're a human. If you're in database work, it's an important application. We need MongoDB, we have to scale. Right? There's a reason why it's called Mongo. If I tell you Mongo, what pops up in your head? What does this person look like? Just ask. Right? And there is a query here, which is also super cool. Super simple. Everything I'm showing here is so simple. Why is it a keynote speech? Because it just works. You know, it doesn't have to be complicated, right? If you have a headache and the doctor says, stop drinking, it works. It's not fancy. Right? So, give me all the tables, see how often did you read sequentially, how many rows did you find, how often did you use an index, and how many rows did you find in average? And we sort it by how many rows did we find. Right? This is going to get you a cool table, and on top it's going to say 500, 3 trillion, million, quintillion rows scanned for 590 million scans, gives you an average super strange number. You look at the table, and usually it's self-evident where the index is missing. It's that simple. It's not going to point you to the column. It's no super cool tooling or anything. It's just take a look at this bloody query, take the first couple of tables, because you sort it out 80%. For the remaining 20%, you have to dig deeper. But the stuff which really kills you is super obvious. Usually, it's super obvious in most cases. Indexing is almost right. The most dangerous sentence in the world. Right? So, observations. Missing indexes, pointless operations, it's more likely than you might think. So, let's take a look after criticizing everybody else, right? Let's take a look at some potential solutions. What you can do to speed up stuff in case it identifies something. So, simple table. Let's create a table with gender. Suppose there's only male or female. Let's assume it's a finite number. Okay, it's not a big number. Gender is not going to be 500. Okay? So, and then we're going to create a table with people. It's a number, gender, and there's some data. So, let's create some data. Let's insert into people. Gender is modulo, so male, female, whatever. We put in some data and we populate 5 million rows. Simple. So, then we run a query. Select name, column star, join, group by 1, 900 milliseconds. How can we speed it up? Any suggestions?
Bring index. Bring index.
No, there is no filter.
Remove group by. Remove group by.
That would make the results set a bit longer if you remove the group by.
Yes.
The problem is everybody seems to be happy, but you could do better. If you do this kind of stuff, it's half the time already. And the answer is buried deep inside the optimizer. Let's take a look at the original query. We join and we group. The Postgres optimizer has to join first and group later. That's the way the code has been written for 20 years. No way around it. Join, group, which means for every person, what's your gender? Number 1, oh, female. What's your gender? Male. Oh, so for 5 million people, I have to look up the bloody gender. So this is why it's 900 milliseconds. In this case, we group by gender ID, which means we're left with 2 entries, and then we do the join. So we only have 2 lookups for gender, right? This is going to get us 500 milliseconds. Okay, super cool. It's one way to do it, right? So once you found how it works, once you have understood how it works, we aggregate first and join later, right? That's a limitation of the Postgres optimizer as we speak. We don't understand must be mirrored. Let's burn the virgin. Anybody want to do it? So the reason is the answer is inside the optimizer. I've done that with Steaming Core. I've turned off parallel queries to make it easier. Okay? So what you're going to see here is Postgres is going to read, it's going to hash the gender, it's going to read for peep, and then it's going to join 5 million rows. And that's where you lose the time. Okay. In the second scenario here, in this kind of period, it's going to aggregate, it's going to sequentially scan, it's going to group, which gives us 2 rows, and then we're going to join. So we're only joining 2 rows. Okay? So this is going to fix stuff. Good news is there is a guy out there from Prague which is working on this stuff. Maybe it can be put into Postgres 12. Let's see, maybe 14, maybe 12. Let's see how we can work it out. It's super complicated optimizer stuff. But just to see that there is hope. There's always hope. So next thing, processing a lot of data. Suppose we have data for 20 years. We have 1 billion rows per year, sensor, count star, whatever, grouped by sensor. Assuming we only have a handful of sensors. In this case, the question is, get me 1 billion rows out of 20 billion rows, which is a bit of a problem usually, because indexing in Postgres is not free. If you create an index on 1 billion rows, what you're gonna get is 25 gigabytes of index, right? So as a rule of thumb, one index entry is something in the order of 25 bytes, right? So 25, 30, depending on what the index is. So, but as a rule of thumb, it's like, let's suppose for simplicity, it's 95 bytes for an index entry. So if you do that on 1 billion rows, that's a lot. And if you have to fetch 1 billion out of 20 billion, the index scan is going to kill you. It's the index scan which is going to drive you nuts. In this case, the limiting factor is random I/O. That is quite often. In some cases, when you have huge index scans, I told you before, indexes are the miraculous solutions. Of course, they are not, because they need space and they're good under some circumstances, but it's not eternally right. There's always a drawback. And in this case, we can do a lot better. And the answer is we can partition. One way. So suppose first row is first year, second row is second year, third row is third year, and so on and so on. So let's suppose every row is 1 year. If I'm looking for the 5th year, I'm just going to skip you all, and I'm just going to take this row completely. I don't have to search for you. I just have to know that you are there. Right? So in some cases, partitioning can be quite useful, especially for time series, because for time series, you're usually checking for a range, do you? Selecting a slice of data. And if you know that it can't be there and it can't be there, this can fix that. Alternatively, there is this notion of a so-called block range index in Postgres, which is a prim index, as they call it. And this guy is super small. First of all, you can create a prim index on the ID. And secondly, look at the size. So the prim index is basically 2,000 times smaller than the normal B tree, roughly, usually. Which is gonna be super cool. So how does it work? It takes 1 megabyte of data and calculates the minimum and the maximum and stores it. Then it takes the next megabyte of data, takes the minimum, takes the maximum, and stores the value. So if you're looking for a value, can't be here, can't be here, can't be here. Okay, could be here, so I'm gonna check you. Next one, can't be here, can be here. So it's gonna take 1 megabyte of data, take the minimum and the maximum, and you're fine. This works nicely if your data is sort of ordered. It has to be somewhat ordered. So if we go for age, 21? 69? Almost, with a couple approximate. That's very bad because the whole range of ages is in here. But if it would be sorted, 21, 22, 23, 24, blah, 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 31, 32, would be awesome, right? So this works perfectly on sorted data. It does not really work with random data. But if often you have sorted data, like time series, tomorrow is going to be a higher date than today, right? And the next day is also going to be a higher date. So it's sort of ordered, for invoices, etc. The next thing, which is often forgotten, is that in SQL you have the idea that you can do many things at once. If I/O is your problem, if you have to read 50 billion rows, it's better to read them once than 10 times. That should be obvious. Right? Reading 50 billion rows, do it once, not 10 times. So you have the concept of doing things more than once. And in Postgres, there are many options. Partial aggregations, grouping sets, pre-aggregations, synchronous sequence. So we're going to cover a small portion of that. Let's take a look at this table once again. Let's do alt the table T person, and let's add the column with age. Let's add age. And then we want to do some analysis. We want to have age per gender. How many people are female? How many people are male? How many people do we have all together? That's the bottom line. How many of them are young and how many of them are sort of young? Okay? This, if you do that with normal group by, this would be 6 queries. If you do that on a billion rows, this means you have to read 6 billion rows. If you do it like that, it's only 1 query. Group by rollup means group by gender and the bottom line. Rollup is going to give you the bottom line, male, female, total. And then in Postgres or in SQL, every advanced database can do that. There is a concept of a partial aggregate. You can say, here we count everybody, here we count everybody smaller 50, and here we count everybody bigger than 50. So we feed the data once, but this aggregate is going to get all the data. This aggregate is going to get some data, and the next aggregate is going to get some other data. So basically what this gives us is 6 statements all put into one statement to avoid I/O. So for analytics, one way to do it is to group stuff into one statement. Okay, that's super cool. The feature is called grouping sets here. So it's grouping sets and partial aggregation. In case you want to look it up on the internet, if you want to educate yourself a bit, it's grouping sets and partial aggregate. Right? So here is the partial aggregate, and here's the grouping set. Okay, how cool is that? So finally, I could continue for quite some time actually. So, any questions regarding diagnosis and some basic ideas of how to fix stuff? Any questions, anybody? Yes, sir.
As you say, indexing is key to success.
In most cases, it is, yeah.
Without indexing, I'm down here for money. If I have in my schema, it's very convenient to me. I have in my schema some sub-document with nested fields, three levels nested. It's very convenient to me. It's easy. Remember, you can index some special in the second, 2 fields on the third field. Here we can index only this bson.
No, in Postgres you can have partial indexes. So you can index on.
I only this one bson. It's increase the space of indexing.
In Postgres you can index on a small set of data. Let's say inside the document only index this part. Or you can have a partial index, say only index the name, don't index the read.
Or function.
Or a function. You can also index on a function. You index on the cosine of your value, something like that. So there are many, many options on how you can do that. Any more questions?
Yeah.
Yes.
Okay, I do agree with you that most performance problems are with queries. Yeah, that's right. But I prefer to debugger over digital statements because you've got a lot more information.
Yeah.
Like if, for instance, you've got like error log, and you can see that, for instance, for instance, something is waiting for the log and so on. Yeah, so we've got templates and we've got ready charts to look on. So do you speech better or like only?
There are many ways to success. The question is this the only way to do it? Of course not. I like the digital statements because everything is in SQL. Digital means your visual.
Yeah.
And if you SSH into a jump host, SSH onto the database computing center, then SSH into the real server, and then you're only allowed to see something. The problem is to get digital from this bank in India onto my desktop. The advantage of digital statements is that if you can SSH,
The other thing that you have to have proper logs configured for PGBadger.
exactly, which could be a lot. PGBadger is fine. PGBadger is a nice tool. It just has to read the log twice and just to read the logs and
Yeah, but it's got like a lot more information, like connection, for instance, which you don't have here.
Yeah, sure. As I said, this is what I've shown here is on diagnosis, it covers 80% quick stuff. Because in many cases, it's the obvious stuff. If it's a logging issue, it's already in the 15% area. I mean, there are many paths to enlightenment. Many paths to enlightenment. That's just one way I found useful for myself, basically. So what I found useful for me, which is fine. Any more questions?
Did you have a chance to look at things like there is a project called OVA?
Index advisor, workload
Yeah,
advisor.
workload analyzer. Basically, what it does, it takes snapshots of digital statements every while.
That's already super cool stuff. You have OVA, you have PGWatch, you have a ton of tools.
Can you recommend any of them?
All of them are fine with you. If you have your approach and it's working, it's fine. It has to work for you, right? There is no such thing as you have to look at these statistics only, because otherwise, Comrade Stalin is going to come to chase you. It's like there are many ways to success. I just try to show something which works for me. So because in some cases, when I go somewhere, there is none of those tools around. There is nothing. There's only plain Postgres because they don't know this stuff exists.
Yeah, but
So I have to be.
on the other hand, you may not have even digital statements, and you don't require server restart to get it.
But what you can still check is PGStat user tables to get a little bit of insight. Right. As I said, many ways to enlighten.
Do you enable statistics of function?
Usually yes. Usually yes, because in some cases you can find something there. It has been useful because when you call this stuff 500 billion times, is there a function which is not marked immutable or Any more questions? Yes, sir.
Yeah. So I have a question about indexing arrays. There are two ways we can put an array into a column.
Index?
Index, yes. Yeah, there are two ways we could put arrays. The first we can
Arrays.
Arrays. Yes. We can create a column int array, yes, and install int array extension and use some specialized indexes for int array extension. Gene indexes, yeah, but they have the specialized classes that could be used for int array. And the second way is to make a column of type JSONB and put an array inside the JSONB and use the gene path OPS index. So my question, what will be faster? Because kind of both.
You have to measure the difference. I can imagine that depends on what you're looking for. You would have to measure the difference. I think it's not obvious. I think it depends on what you do.
We are seeking for integer number if integer numbers are there. For some integer numbers, but it's very small set of integer numbers, maybe 5 numbers.
My feeling is that the inter-AD is going to be faster, but that's just the feeling. I never benchmark.
Mm-hmm.
But feeling is
The inter will be
feeling,
good.
not wisdom. Any more
Yeah,
questions?
thank you.
Anybody? Yes, sir.
We have some situations that we have a lot of data and we partition data by day.
Yes.
And sometimes we need user information across the whole period.
Yes.
Is it a good idea to create a Brin index for a user or B3?
I wouldn't think so because it might be true. Okay, any more questions? Yes, sir.
You mentioned like change misses, yeah? Can you tell a little bit more like from the inside how the black box actually works in Postgres, how it evaluates, how it predicts, yeah, you know, like some sort of algorithm to choose this way or that
Oh,
way.
that would be 10 hours.
Really?
That would take 10 hours.
Okay.
There is one of those books has I think 50 pages on what the optimizer does, and I'm pretty sure I missed half of it. Any more questions? So we are cool. We have euros, and we're looking for skilled, talented people to join this gentleman over there. So in case anybody is hopeless, unemployed, living under the streets, feel free to call us. So thank you very much for your input. Отже, в нас буде піца, але поки що без пива. Вона трошки затримується, тому ми пропонуємо зараз ще одну доповідь, а після неї вже буде трошки коротенька перерва. І ми роздамо всякі різні мерч, є наліпки, є ручки, сирники, таке інше. Не забувайте, підходьте, ми вам все роздамо. Добре? Домовились? Lisa, would you please...
So now we can say.
Yes. So we have pizza, and we think that you should. Oh, we don't have pizza now. It's late, so we think that you should give your talk now, and after it we will have the little break. Are you fine? Okay. Will you speak Polish? Хто розуміє польську? Ладно. Well, if we will speak slow, fancy stuff. I will give you some. No problem. Я хочу нагадати нагадати, що в нас сьогодні будуть наші спікери, хвилинні доповіді. Якщо у вас навіть немає слайдів, всім окей, приходьте, співайте там пісень, або ще щось. Жартами.
Okay.
Давайте привітаємо Алісу, вона буде розповідати нам.
So my name is Angela Patrick. I'm from Warsaw, Poland. I will speak English. Actually, Polish if you want. Maybe I work as a senior solution architect for Link Polska. And I will be talking about that's not really the topic, because the tests were made on Lviv database. But the talk is really about tuning operating system for every Postgres database. So it's not about something that the data happens. I will tell you why I did those tests. I will tell you about the data. I will tell you how I did the test, and I will, of course, provide you with some theoretical background about those parameters. Okay. Now you hear me better.
No, it's for online users.
It's for streaming, sorry.
Yes.
Okay. Okay. So, like Hans, I had an interesting case by one of our customers, and it wasn't this time the bad SQL. It's really like 80 or 90% of the cases it's bad SQL, but this time that wasn't the case. It's been something probably NUMA dependent. It's NUMA, it's non-uniform memory access, so it's much, much deeper than the SQL query. And there was actually no chance to debug this case in the production, because it's been a banking server, and only on this big core banking server this issue was. So no testing environment, anything like that, which would be similar to the production server. Okay, so I've tried with hosting, but it's really hard to find 4-socket server in a hosting. I found maybe 1 or 2, which were really expensive. So I decided to buy like my own for-real server. Yeah, it's next to the TV, so on the chair, so it's really professional. It's got 4 sockets, a lot of RAM, as you see. So it's 128. Giga, and for SAS disk. Okay, you've got the environment specification. It's of course Linux in CentOS 7. Yeah, so quite new. Okay, and not about this case at customers, because when I bought this server, I wanted to test first something else. The case was the reason why I bought the server, but I wanted to test first something I do like at least once a month at every customer I go. So it's like Postgres health check. I'm always starting with audit 0 or Postgres health check. And during this health check, I'm doing 3 things: OS check, database check, and query check. So you've got a lot of parameters in operating system, in Linux. I will tell you what every of those means, why we choose that for Postgres. But okay, it's in every report really. So I haven't changed this last one since the conference, so it's still in Polish, so sorry. But I think you understand better. So it's read ahead in English, often z wyprzedzeniem. How is it in Ukrainian?
Випередження.
What?
It's in Ukrainian.
Okay, so let's name it read ahead maybe. Okay, so I always put this table in my report. Those parameters you see here, you can use actually for your production systems. It's like Red Hat recommendations. Those are a lot of companies that do some Postgres consulting, like Cybertech, I think, is doing similar stuff, like checking those parameters. Okay, but really, I always recommend that based on some solid books, based on documentations, but never really did any solid benchmarks. So just wanted to use the server to do benchmarks. Okay, the data come from one of the Polish public institutions, and they've got like a lot of servers, really a lot. And they need to monitor those servers, and they're using Zavis for it. It's I think a couple thousand of servers they do monitor. So this Zavis database is really big. It's like 3-4 terabytes in size. Okay. They've got on production one PostgreSQL instance with one hot standby and quite a big server for that. And the server after tuning, it's like not even 1% load. So it's really working well. Okay. Maybe I will not tell you too much about this data extraction method. Of course, I did dump. I took text logs from the production, so the real production load, and you've got like the tool that is able to parse the logs and like replay the logs somewhere else. So you can simulate the real production load on completely other environment. So if you've got dump from the production, you can of course restore the dump, and then you can like play the same load that was on the production server. So it's really great tool, not only for tuning, for regression tests, for a lot of different tests you can imagine. This tool, okay, maybe how those results were, what's the result where it came from. Every test were done like replaying the log against the production database on my server, and every single test took 1 hour, so it's quite a lot. It's like the full automate. So the server got a list of tests it has to do, and it's taking, for instance, the first parameter, is changing it, is running the test, so replaying the logs, and gathering a lot of statistics, a lot of data during this replaying thing. Okay? And after 1 hour, the PG replay, so this tool that is replaying the logs against another server is killed, and the server is rebooted, and the next test is going on. You've got here some basic configuration parameter I used. Of course, auto vacuum was off because I didn't want any interruption in my tests. log checkpoints, so a lot of logging, because I do like PG Badger, and PG Badger uses logs, so text logs, to show you the HTML report there. So I needed a lot of logs from this test server to parse and to get some statistics about this test run. Okay, this is the tool PG Replay and how those logs were replayed. It's been like a fairly the load of the production server isn't really that high, and if load is like 0.1 or 0.5, that's not really something that can be very hard for the server. Every server will like do it without a problem. So those differences between test runs wouldn't be really big. So I needed something that really kicks off the server. So the load going high, so I can see the bigger difference between test runs where I do change the parameters. Okay. Okay, and data from this test server were written to another DB just to keep the statistic data somewhere else, and yeah, and then get the data to work on. Okay, let's start with the first parameters. I was talking about parameters, about Linux kernel parameters that are commonly tuned for Postgres. I will start with the one without a movie, sorry, because I forgot it from home really, so it's laptop and forgotten to take them. Oh, thank you. Yeah. Okay. Yeah. So the first one is called overprompt. What does it mean? If you're running some process on Linux, Linux in most cases will give this process that much memory the process needs without checking anything. So it's called overprompt. So it's giving a lot more memory, a lot more resources that process needs. And as you probably figure out, the OS could give it too much memory to process, causing so-called OM. It's out of memory killer. So out of memory killer, causing that the process is killed. So maybe it's like one process that's that only one query is on, but it could be the postmaster process, so the main Postgres process. Yeah, so your whole database is down in this case. It's been killed because of out of memory killer. And that's actually the most important Linux kernel parameter to set if you want your database to be safe. You've got three possibilities: 0, 1, and 2. 0 is the default one, so it's using like heuristic algorithms, so your process can have more memory than he needs. So it's not really counting anything, it's counting but something, but not really exact. 1, it's not recommended for any database load except Mongo, because Mongo is really strange. It's actually in Mongo documentation that you should set this parameter 1. 1 means always overcoming. So it means if you've got like 32 gigabytes of RAM on your server and your process wants 3 terabytes of RAM, okay, give it. Okay, Linux hopes that the process will not use the whole memory given, yeah, but yeah, it might. So, OM, yeah, your database is down, server something's done. So only right setup for this parameter is 2. So never overcome it. So never give your process more memory than it needs. Okay? It's the only one that's right for the database world. So never overcome it. Okay, yeah, that's the movie I forgotten. I wanted just to show you that that's on the movie. How does switching these parameters from the default to 2 really cause that you don't have overcome? Okay, so you've got actually 2 parameters that are about overcoming. The first one I've been talking about is overcoming memory, and you've got like 3 flags: 0, 1, and 2. 0 is the default one. The second is the 2 is the right one, and 1 is right one for Mongo. Overcommit ratio, it's something you need to calculate for your system. So how much of the memory plus swap the process can use. And you've got here results of my tests. 1 hour test, and I took not really 60 minutes, that's here below, it's the time, and it's always been, I took 0 here. So for instance, I started the test at 1 p.m., but it's always 0, okay? So start the test is 0, and I took average on every minute. So it's easier to compare the data. And here you've got numbers of TPS. So TPS are transactions per second. 0, the default one, is heuristic algorithm that sometimes cause overcoming, sometimes not. And you got that one here, that's the blue line. 2 is the right one. Okay, so it's the worst one, right? The reason is the worst, but that's not the parameter you should tune for performance. This parameter you should tune for safety, okay? And it's a bit slower, right? Of course, this one always overcoming is the best, obviously, but yeah, if you're not using Mongo, don't use really one. The same recommendation is actually for Oracle, for every other database. I mean, database. Okay. And how much memory those Linux can offer to your process? It's been 50. 50 is the default. So if you will change the overcommit memory to 2 and stay with this 50, you probably will waste the memory. Because system will not be able to use the whole memory. And for instance, I've got customer with 6 terabytes of RAM, and they've got overcommit memory 2, and overcommit ratio set to default, so 50. And they've got like some really strange settings for shared buffers as well. So they are like wasting about 2 terabytes of RAM in total. They're having 6 terabytes of RAM. Okay, it's something more. It's that's the 80 and 91. So it's the first one. So it's the best one. Yeah, quite obvious result. Yeah, you've got more memory. Your performance is better. Okay. Okay. Hopefully you know that Postgres doesn't have something called direct I/O. So it's not like if Postgres wants to write some data, it's not doing it directly to the disk. it's always, Postgres always uses undirect calls, it's called calls, through the operating system. So it's using call to operating system to write the data. For instance, when we're doing checkpoint, which is default every 5 minutes, Postgres will send the call to the operating system to write the data to the disk for Postgres. Okay? Another database system like Oracle have got like direct.io, so it's direct communication between database and the disk. Not in this case. Postgres has always calls to the operating systems. Operating system itself has got his own buffer where he keeps those dirty buffers. Do you know what dirty buffer is? Oh. Okay, so if you've got the buffer, yeah, when it's like read from the disk, it's clean. But if you change anything in this block, in this particular buffer, it's called dirty, and it needs to be like write out to the disk sometime. Yeah. Every 5 minutes, for instance, when it's written to the disk by the checkpoint. Okay, so Postgres has got its own buffer, then it's doing checkpoints, so it's sending those buffers to the operating system, and operating system has got another buffer where those data are kept. So you've got some tunables in operating system for this buffer. The most popular one are dirty background ratio and dirty ratio. Regulating the space that operating system can use. The daemon called pdflash is starting asynchronously writing to the disk. Okay. And those dirty expired syntax and dirty write-back syntax are telling us about the time. So how long those dirty buffers are kept in the cache before they are write out to the disk. Okay, let's maybe I will show you the picture here. So how it works. So we've got at first, we are just starting up the database. We haven't done anything what could cause the buffer to be dirty. So everything cache is completely clean. Okay? It's nothing happened. After some times, some buffers are dirty, and when the number of dirty buffers is 10% of your RAM, that's the background one. So dirty background ratio. That's the parameter that tells you that that's the default value of these parameters. So the default one is 10%. Dirty background ratio. And here, asynchronous process, this daemon called pdflash, is starting asynchronously to write out the data from the buffer to the disk. So it's slowly starting to write out. And here, that's the default value, 20% of the second one, so the ratio parameter. And here, if you get to this point, all the writes in your system are stopping. So there's no such a thing like asynchronous writes anymore. There's only synchronous, so all the writes are stopped, are stalled. And the system is waiting for those buffers that were here before to be completely written out to the disk before it starts new I/O operations. So it could cause a really big problem in your database. Everything is like working, waiting for the write-up. Okay. Okay. And dirty background creation, it's here. So when the system will start to asynchronously writing out the data. That's the default value, it's 10%, that's 0. So it actually means every time the buffer gets to this buffer, yeah, the buffer gets to this cache, it's getting right out without waiting to anything. The 5, it's the volume between those two. Okay, so it's turned out was strange. It's a bit strange for me, really, that the best result was with the 0, which actually means that there is no cache in operating system. So it's a bit strange. I think with other data, with other system, it could be different, really. But for this particular Zabbix, for this particular system and field, this value is the best. Okay? I don't think it's like universal thing to set everywhere like 0. Maybe it should be 1, maybe it should be 2. It's the remember, it's the percent of the RAM you've got. So if you've got 1 terabyte, 1% will be 10 gigs, right? So if you've got really huge memories, you probably want it really, really low. Maybe not 0, but 1, 2, or something like that. Okay, dirty ratio. So it's the second value. When Postgres, when the OS operating system, your Linux, stops asynchronous writes and waiting for all the buffers get synced to the disk. Okay, it's almost the same, almost, right? It means turning totally off our cache. And I don't think, I haven't checked that really, because I haven't have like cut cross mem info gathered to anywhere, so I haven't checked it. But I suppose the system never got here. Right. So it's always it's more like. Yeah, it never got here, so that's like almost the same. Okay, what's the huge pages? Huge pages are kind of a new thing for Postgres. Maybe not that new, because the support for huge pages came in 9.4. And what is it? The standard operating system page is 4 kilobytes. It's 4 kilo. Sometimes if you've got really a lot of RAMs, a good idea is to switch from the 4K pages to something bigger, like 2 megs, 1 meg, or even 1 gigabyte. It depending on your CPU architecture or which size you have on your system. Why is it useful? And I need to say that for systems with a lot of RAM. Why? Because it's something like mapping virtual page addresses to physical page addresses. Something that translates those two addresses, and it's in TLB, those are in, for instance, wants to allocate like 100 gigabytes while loading, or are you doing like a select star from real big table and you're getting 100 gigabytes in results. So you need to divide this 100 gigabytes with 4K. So you need a lot of 4K pages. You don't need that many of them. You need a lot less, so it's bigger chance to get hit to the CLB cache. The CLB cache, which is holding this mapping for the virtual and physical addresses for the page. Okay. And I set usually those huge pages for customers that got like at least 74 gig of RAM, and it's working really well. It's working really well for your CPU. Okay, CPU load is getting really lower when you're reading huge pages. And there are like two kinds of huge pages. One of them, those which support was added in Postgres 9.4 are pre-allocated at startup. So it's that one. And the second one, it's something called transparent huge pages that is allocated dynamically during runtime. And the interesting thing is that this one is okay, this one is fine and could help you a lot. And those are really like this disaster for the database load. And if you look at Red Hat recommendation, for all database load, the transparent huge pages should be turned off. Okay? Because system is all the time like scanning the whole RAM, looking for pages that it needs to be continuous pages, 4K pages that can allocate and make one big page from it, like 2 megabyte page. Okay, and it's scanning this RAM, scanning, allocating, changing some data. Then it's freeing those pages. It's really like bad thing for your database load. But if you can allocate, can calculate earlier how much huge pages you would need, then and use it just those pre-allocated huge pages, it could be really good. And transparent huge pages are enabled by default with Red Hat Enterprise Linux 7 and those versions and distribution which you see here. So if you've got transparent huge pages on, really go and disable it. It could do a lot of harm. Yeah, so it's one of the first things you should do. Okay, with my load, with my data, with my system, it wasn't really a big difference. This time, no. Maybe there been no like big operation like reading data. Our system needed a lot of pages to work on. Maybe it means something else, but here it's actually without a difference. Okay, that's really interesting one. I haven't investigated it any further, but it should be another way around, right? Because that's the default always. So always use transparent huge pages. So yeah, always look for this continuous memory areas that I can allocate for huge pages, and do extra work. And huge pages, when I have allocated this, when I have pre-allocated it, there is no difference. So that's really strange one. That's really strange one. Okay, read ahead. I'm not sure you know this book. No? That's okay. Okay. That's really like my favorite Postgres book. It's a lot of tuning advices there. And the author of the book, Greg Smith, tell us that the first parameter you should tune on any Linux install is the device read ahead. But it's really like on old book. An old book from the time that you could not even get like 6 terabytes of RAM to your server, that you could not cache the whole database in the RAM. So maybe now it's quite important, but maybe it's not the first one you should tune nowadays. Okay. What is it? If we've got a system call, for instance, we are doing select star from something, so Postgres would take, let's say, 2 pages to 2 pages from the operating system. But this parameter tells, okay, but probably you will need some more pages later on. So instead of 2, so take 4 or take 6. Okay? And you can tell the system how many of them you can take with this call. Okay? So it's read ahead. Read before any query will go. And you've got those values are in blocks. So in 8 kiloblocks, no, it's 4K. It's 4K multiplies this number. So how many blocks you take doing some I/O operations. And yeah, that's a bit strange result. The best is, okay, the best is here, so 60,000 blocks, but that's quite surprising. Swappiness. I assume you do know what swappiness is, and swappiness parameters tells you how aggressively you should swap the memory. The default value is 60. Yeah, default value is 60, and in this book I told you about before, it's a recommendation to set it to 0. So no swapping, The system starts to swap only when it's really, really bad. Okay, that's what the 0 means. The safe setting is about 10. So it's swapping a little bit less aggressively, but yeah, it swaps sometimes, not only when something really bad is happening. And the good thing is, going back to these huge pages, if you've got normal, not transparent, normal huge pages, Linux kernel cannot really swap huge pages. So if you've got, for instance, your shared buffers on huge pages, Linux will not swap it to the disk. Okay, so you are safe with swap. It could swap the rest of memory, but not shared buffers on huge pages. Okay, the default values is 60, that's 0, and that's the 10. So it's here, it's only in some really bottleneck cases do swap. My system wasn't swapping a lot during the test. Here 10, so it's less aggressively, and that's more aggressive. So it really works. I haven't tested like corner cases when I was doing like load that my server could not process to check it. But you see, there is a performance gain to change the swappiness parameter. Mount options. Okay, you've got really a lot of mount options. Depending on the file system you use, I've used XFS, which is stable, which is recommended by Red Hat and other big companies, or like AX4. And actually, I will show you the result of no time. It means that system will not change the access time, for instance, when you are reading the file. will not change will not still changing access right modification time of your file. So you don't, you will not have another I/O caused by this this time changing, so starts changing. And I have to say, I will not tell you this about I/O barriers because I think I don't have that much time. Yeah, I don't have that much time. So I will tell you about the test I've done like 3 or 4 years ago. It's been on banking system, and those days I checked this no time setting. And really after my test, it was like this no time function doesn't have any influence to the performance of the overall system. But in those tests, this no time was the best among any other options. So a lot of parameters I'm talking about really depends on the system, on the load, on the hardware you've got. So not everything is like a recommendation for every system. It's not universal. Sometimes you probably will see some performance gain, but in other systems, learning this time writing thing will not help you. At all. Okay, I/O schedulers. It's the way how blocks that are supposed to be written to this are scheduled, like put in line. So how they are written to this, how they are queued in order to be written to the disk. And in this book, that's the last fragment from this book. Greg has written that this one is really like the last parameter you should tune if you should tune this parameter at all. So like you see, the least effective tunable mentioned in this section. Yeah, so he said it's not important, but I heard people that told me that changing the scheduler cost the system like performing 100, 200 times better. Sorry, for 100%. Okay, better. Okay, you've got 3 most popular schedulers: no-op, deadline, and ZFQ. Red Hat again is recommending the deadline. You've got a lot of advices, like if you've got virtual machine, you should for instance set no. If you've got physical machine, you should use deadline. But I don't think it's like really any rule for that. You need to change it and test it. Yeah, that's the last, sorry. So that's the last one from this book. Anyone who tells you that either CFQ or deadline is always the right choice, that doesn't know what they are talking about. Yeah. Yeah, I will not be talking about that. I will show you the result, and yeah, in this case, it really doesn't have much influence on my data, on my performance. Okay. Oh, it wasn't. Oh, that's not the book, it's the documentation. So okay, I'm safe. You've got this one, so it's advantages if the log is located on a different disk from the main database file. And if you're at Google or Postgres tuning advice, you will probably see something like separate the wall files from your PG data. Then you will have like 60% or 100 or 200% performance gain. That's really often the first thing that people do when they tune Postgres. Okay, so separate the walls. Separate the walls. The best idea is to separate it to another disk. But sometimes there is a reason to not do it. For instance, if you've got like big enterprise and your big arrays, big professional arrays, you cannot really plug in separate this, for instance, like pendrive, and put the walls there. You need to use this arrays, super brand new. But separating into another loon where you put another file system, it got some advantages really, because you've got another file system queue. So every file system has got separate queue, writes, reads, and you separate the queue from the main database where the load is mixed, like reading, writing, reading, writing, and in walls you've got like write. Okay. So what's to separate? Walls, of course. The first thing you should separate is walls. The second one, maybe indexes. The third, temporary files, sometimes. Temporary statistics data, and you could use even RAM partition for that. Error logs, so I meant the text logs, so PG log or just log in Postgres 10 or Postgres 11. Highly read or written tables. Because of this pattern, if you've got the pattern like read, or write, you can check it in pgstat user tables. How many writes, how many reads it's been, and you can separate those two things. And really, I did this one on the Zabbix database, because in Zabbix you can do something like partitioning of history data. There's something like that, and I put it on separate partition, and I've seen like. It's been all a bit better. Okay. Those results were quite surprising, really. It's been really surprising, and this week, really, because I was really, really surprised by those results. So this week, I ran like not 1 hour, but 4 hours test for every of this setup. So separate logs, separate logs, just type text logs. Separate logs and walls together, and everything in PG data, so the standard setup. And I rerun those tests with 4 hours, not 1 hour, and the results were the same. So, okay, I will tell you what that means. So, that's really like a much better performing case. Yeah, this is the best one. So, separating text logs, not wall logs, text logs, to another file system. And those three, are the same. But by separating logs, here are worse than default one. Right? So it's like the first advice for tuning Postgres, separate the wall. Yeah? Yeah, so my Postgres will perform worse. Yeah.
Maybe different disks, SSD and
yeah, I want to do that in another set, but now it's been like different file system all. But you still got this file system queue on the other file system. So.
And what's the logs about?
Logs, it's text logs.
Yeah, but what's this for them? Because you can log a lot of things.
Yes,
so
it's been full logging. on the one of the first slide, like it's log mean duration statement 0, so it's been logging everything with checkpoints, with everything. It's been like about 3 gigalogs of
Just
every
means
test.
your text logs are bigger than
Yeah, but why it's worse than without separation? That's the question. Because the second test, this 4-hour test, just shown me that it's still worse. So, and separating walls and logs together, it's the worst things of all of them. It's really much better pictures on PG badgers when you see those pictures. Okay, actually, do you have any questions?
Yeah, it's been asked, but I think I missed it. So you were separating this data on different volumes, but those volumes were on one physical
Yeah.
device.
Yeah.
Yeah. Thank you.
Yeah, I had no chance really. I don't have disk. I want to just buy those disks now and do those tests.
Yeah, I bet the author meant that under volume meant the separate physical device with separate like file system on it, so that connection from operation system goes to a different device.
Connection from the operating system.
Yeah, like data from the operation from memory goes different way. Not all the data go in the same in the same channel to one physical device, but uses different channels.
Yeah. Okay.
That's because the physical device has its built-in cache. Yes, and that cache, there is some controller that controls that cache. And that cache could be like overwhelmed.
Yeah, that's why I want to buy another disk like SSDs and just to check that.
Yeah,
to do
yeah,
the
because
walls,
those
we
devices
don't
will
separate.
have their own cache,
Yeah.
physical caches.
I know, and I want to test it as well. Now I don't like test for separate file system. Just.
Well, thank you.
One more question about huge pages.
Yeah.
What's your recommendation about number of huge pages? Should it
Yeah.
for depends on buffer cache of Postgres?
Oh, shared buffers, yes. Yes.
So actually, the same size, a little bit more.
A little bit more, yeah. You need a little bit more because if you would set the same, Postgres will complain about that and will not allocate. So it's a bit more, and it's better to give it like even much more because it's easy like to do it like less when system's running. You don't need to restart it or anything. But if you want more, then you need to restart.
What is your recommendation about buffer cache for Postgres?
Wow.
It's
Depending-
25%, 75%.
No percentage. You need to know your database size. You need to know your RAM. You need to.
Database size is much more than RAM.
Okay, so probably you should go really low, like 2 gigs or something, if database size is bigger than RAM. If you cannot really keep everything in RAM. So start like 2 gigabytes, test it, and maybe 4 gigabytes. You've got this great shared buffer size. Yeah.
Wanted just to add that the reason it could be in processor, it could be like prefetching, you know, and when you like don't do separate hard drives, the change misses are lower. So I don't know what processor
You are probably
you use.
talking about separating those
If
walls,
there is
right?
like virtual cores, you know, and they have like the same change level, so the input output are really expensive operations. So if you have like less hard drives, like all in one, it's pretty like obvious that this should take less time. So
You know, I was thinking about that, but you know, log like text logs are much bigger, so need a lot more space than walls.
well, today's processors like that they do prefetching like really crazy. So this is the only explanation. Like simple. Like,
Yeah, but I think about that, but really I think it's been like a lot of logs, a lot of text logs, not that much of all logs. So why, why those text logs are supposed to not, why text are supposed to fit into this one part and wall logs not? That's a bit strange.
all cores were physical, or there were virtual cores?
Only physical, yeah.
Interesting. Cutting to the chase, was it worth it to do such an experiment? You solved this business problem for your client?
No, it was really, I'm going to test this case, but I wanted first to do this test about this operating system tuning because, I always wondered why those people say those things in books and documentation. So I need to check it by myself if that's really true or not.
So it's like proof of work concept, yeah?
Yeah, definitely.
Let me get it clear. What those logs were about? Those were the logs that record all the queries that go into database, or it was.
Just, I didn't hear you well. Yeah.
Okay. What those logs were about? Like what mode it was? Like all or?
Yeah, log mean duration statement was 0. Log checkpoints, log connection, log disconnection. So everything, actually, it's been on the one of the first slides. So it's been actually everything what was happening in the database. So it's been, yeah, everything, really everything, even select one. Yeah, that's the first. Go. There's maybe like the first slide button. No.
So it wasn't only about queries. It was just log everything.
Oh, that.
Very deep logs.
Yeah, it's been somewhere. No. It's been this slide. Oh, that's the one. Yeah, log connection, log checkpoints, log auto vacuum. Oh, it really makes no sense, this auto vacuum make duration because auto vacuum was off, but log 10 files, and you see log mean duration. Oh, here statement is right 0.
Can you turn to processor? They have similar, so they share all the change. Your processor server, they share change.
They are like human, so it's for sockets, so they've got separate virtual applications. Hans,
Yeah, I have a question. What's really interesting is that your charts always break apart after 17 to 20 minutes. Before everything is uniform, and then you see the changes.
Yeah.
That's what struck me. What's your theory on that? It's cache warming or something?
Yeah, that's really.
Because before everything is always the same for most of them, but then it starts to separate.
I will show you something. What's really like interesting. Oh.
And she made me
I think, yeah.
I will show you that later because some people
It's super interesting because
yes, because I've got like in pgbutter when you've got like average execution time of the query, there's always like something like that.
Yeah.
Yes. So I suppose it's something with the cache because there's no such a with some parameters you don't have this hole here. Yeah, and with some you've got like real big one. So I will show you later those pgbutters and yeah, we can analyze that. Yeah.
You use it pair as a suffix and right. Have you ever used Delta's open source monitoring system as a Xenox or lighter Unix platform?
No.
No, never.
No. It's Zabbix. just like Zabbix is really nice, so I really like it. Okay. Any more questions?
Default size of working memory on the Postgres configuration and null customization of checkpoints.
There's been no customization yet.
And default size 2 megabytes for memory.
You mean like workman? Yeah, it's been default. Yeah.
Default one is for 16 now. So this has been customized.
It's been, I will check because I changed it during the test. I will show it's probably large. Yeah, it's 2 megabytes, right? I changed it. Yeah.
Any reason for that?
I didn't want everything to go into this. So, almost every query would make temporary files on the disk if the workman would be default. So I wanted to have like half of it's.
Is it right?
Yeah, that's right. I don't remember.
Default is 4, or maybe 16 for the latest.
Yeah, it's been 10. I don't know. I don't really recall. It's been a result.
So this will generate a lot of temporary files.
Don't really remember because I've changed it like 3 times. Don't remember the reason.
All the settings are changed, like maintenance of memory, first buffer, and this one is. This looks strange.
Yeah, I know. But I don't remember. I need to go through my notes to see why I've changed that, but I don't really recall now. So okay, all the questions. Okay, so thank you.
Зараз запрошуємо всіх тут трошки далі по коридору. Там вже кулуари. Вже всі чекає піца і заберемо напої. І потім повернемося назад. У нас вже є 2 сесії на лайфі. Можливо, під час перерви ще хтось зголоситься.
Нас і на то ми ще будемо писати.
Вот настрой собак.
А ти що хочеш? Якщо ти голодний, можеш.
Да, иногда полезно.
Таке питання. Презентації і друга.
Передивитися ж, попробувати. Смішно.
Ну,